Hello, everyone. This is the video solutions for your first exam. I'm hoping that almost all of you in the end decide to watch these videos because I think that there will be helpful information, but especially those of you that need to retake the exam, I think that this will be helpful. So I'm going to break the videos into two sections. I'll make a multiple choice video and then I'll make a free response video. I'm also going to try to show you on the practice test the ideas that showed up on the test. So I'm going to try to show you what problems were related so that hopefully that can help you study for your retake if that's something that you're planning to do. Also, I'm going to try to put up the number that I'm doing. So if you look on the screen now, I'm going to start with number 1, obviously, so that if you don't want to watch the video solutions for a problem, you can drag the thumbnail down at the bottom of the video.
Mr. Euchre, please call the main office. Mr. Euchre, call the main office.
So that you can find the problem that you actually need without having to watch all of the video. It may be helpful for you to watch most of it because, like I said, I'm going to go through the test problem and then the practice problem, show you how they line up, and then talk about what kind of flashcard I would have made in order to study for that. So it may be helpful for you to watch all of them, but if you don't want to, at least you'll be able to have a way to scroll forward and look for the problems that you feel like you actually need. Okay, so that all being said, let's get started. Okay, so we're starting with number 1, as I said. And number 1 is asking you for which of these variables would it be most appropriate to use a bar chart. So you had something similar to this on your practice test. It's number 8, and it gives you a two-way table and asks you a similar thing. Based on the table, what is the most appropriate graph? So this one gives you the variable and tells you what would you use to graph it. The one on your test gives you the variables and gives you the specific graph. So they want to know bar chart. So I guess these are almost exactly the same. No, it's backward because this one, oh yeah, it is backward. This one gives you the variable, wants you to choose the graph. The one you got on the test gives you the graph they want you to use. You tell them what variable can be made into that graph. So on the practice test, what this problem would have told me was, I need to know what different graphs I can use for each type of data. So if I have categorical data, I can only use a bar chart or a pie graph or a two-way table. There's only 3 options. And this goes back to that very first page in our data lesson, where you have a graphic down at the bottom that shows you if you have categorical data, these are the things that you can use. If you have quantitative data, these are the graphs that you can use. So then I would have made a flashcard that said, and I'm pretty sure that we have one, what types of graph can you use for categorical data and what types of graphs can you use for quantitative data. So I'm actually going to pause the video and see if we do. So I found them. It's flashcard 2. What can you use to display quantitative data? And it's flashcard 1. What can you use to display categorical data? So the first 2 flashcards that we made have to do with the first question on the test. So then the only other thing that you would need to know is, well, what is a categorical variable? What is a quantitative variable? and that is flashcard 10 and 12. It goes through and reminds you what is quantitative data, what is categorical data. So not only did we have flashcards, but we also had a question on the practice test that matched specifically to this question number 1. So then the only other thing that you needed to do was go through on these answer options and decide what type of variable they are. Favorite sport, categorical. Gender, always categorical. Height is a number, quantitative. Eye color, categorical. All of these variables should be graphed with a histogram. No, histogram is only quantitative data. So your only option is C. Your only option is C. Number 2, sorry, let me get my little thing going. So now we're on to number 2. So they want to know which bar graph matches the pie chart, and there really is no direct flashcard that we can use on this, and I'm not sure there's really a direct practice problem. I'm just checking really quick. Yeah. So on this one, you just need to have a good understanding of bar charts and pie graphs. So you want to look at the different sizes of the bars compared to the sizes of the slice in the pie graph. So hopefully you're noticing that the US needs to be the biggest or the longest bar because it's the biggest part of the pie. So that eliminates option C because the US is not the longest. Then the next thing that I would look at is Japan. The US has to be like about twice as long or a little bit longer than that than Japan. So now I'm comparing this one and this one. So I'm going to go over and I'm going to compare Japan to the US. This one is no, because the US is for sure twice as big, but this bar is not half the size of this bar. So A is not right. B, okay, this could potentially be it. D, no, again, for the same reason as A. Japan is at least half the size of the US, but this is more than half. So our only option is B, and the two countries that I compared were the US, and then I went to Japan. It may be helpful to check the other countries if you're not sure. So for instance, Germany has to be smaller than Japan. So I can come up here and just double check. Yes, Germany is smaller than Japan. Italy and France have about the same size slice, so they are the same size bar. So just by comparing the two largest slices, I was able to get through problem 2. Problem 3. So this is one that was, I wouldn't say commonly missed, but this is one of the ones that if you missed problems on the multiple choice, it was likely one of these. So, of the people in the study who had cancer, if you see the word of or if, that always means you have a condition. And whatever comes after those words has to be the bottom. So whatever comes after is the bottom of your fraction. Now, I did make a flashcard on this for myself. If it doesn't take me 10 years, I will try to find it. It was the how to read or use a two-way table. So I took my two-way table and wrote down a couple of questions, and notice that I even used this phrasing: of those who lived, what percent is female? And down here, you can see the number of people that lived was 711, and the number of those that are female was 344. So I did have a flashcard that matched this problem. I'm seeing if you had any in the practice test that would lead you to this. Number 15, he was one of the more complicated ones, but this is going over the if situation. Now, none of these said if, so hopefully between this problem and this flashcard that I added in, that explains why in the bottom of your fraction, you need to use the number of people who had skin cancer. Of or if, whatever comes after that is the bottom of your fraction. So the number of people that had skin cancer was 896. And of those people, how many of them used a tanning booth? That is 190. So it has to be B. Number 3 was B as in boy. So the biggest takeaway is if you get a two-way table, if they use the word of or if, whatever comes after goes in the bottom. If they just use the word and, that's not a condition. You're looking for words like of or if or given. Given is another word that they might use. If they just use the word and, it's not a condition. What do I mean by that? You had that basketball problem in your practice test, and they said, what proportion of the games did the Cavaliers win and have a short rest? Notice they're not saying of the games that they won, if they won a game, given that they won a game. They're not saying that. They're saying you won and had a short rest. So hopefully that helps out with number 3, because you will see this on the retake. Number 3, the ideas in number 3. You will 100% see this idea in the retake, for sure, without a doubt. Next one is like a sideways segmented bar graph. Oops, I gotta write number 4. Sorry about that. Okay, sideways segmented bar graph. And along the bottom, they're giving us percentages, which is relative frequency. They are not telling us how many kids are in these grades. They're not telling us the number of students. They are giving percentages. So the first one says, of all the students who chose activity B, the greatest number of students was grade 6. Not even an option. We do not know the number of students. We only know the percentages. So we cannot compare the number of students from grade 8 to grade 7 because we don't know. Option B, grade 7 and grade 8 had the same number of students who did not choose activity A. Can't use that one either. We cannot compare the number of kids between 2 different grades because we don't know the number of kids in those grades. Option C, the grade with the greatest percentage of students who chose activity C was 8. So go up to activity C and you're looking for the longest bar, for the gray bar. So I come up here. Grade 7 had the longest bar, which means grade 7 is the one that had the biggest percentage of kids who did activity C, not grade 8. So it's not grade 8, it was grade 7. D, for students in grade 7, so we're only comparing students in grade 7. The number who chose activity C was greater than the number who chose B. So we go up to grade 7 and we look at C, activity C, compared to activity B. So in grade 7, which bar is longer? The gray bar. For grade 7, 40% of the kids chose activity C, and it looks like 36-ish % of the kids chose activity B. So if there are 100 kids in grade 7, 36 of them chose activity B and 40 chose activity C. So D is true. If I'm comparing only the 7th graders, I can say the number that chose activity C is greater than chose activity B, because of grade 7, a bigger percentage chose that activity. So I can compare the number of kids within the same grade level, but I cannot compare the number of kids between different grade levels because I don't know the number of kids between the grade levels. But I can, within the same grade level, use those percentages, because no matter how many kids are in grade 7, a bigger percent of the 7th graders chose activity C. I cannot compare amongst the grades, though, without knowing the number of kids. If this is one you're struggling with, you may need to come and sit with me so that we can go through it with numbers instead of just talking in general. Okay, up next is 5. At a certain school, 60 of the 100 boys and 60 of the 80 girls signed up for the senior trip. Is there an association between gender and the trip? So association always depends on what variable? When you talk about association, what variable do you care about the most? So I'm going to pause the video and see if I have a flashcard on this. So I didn't have a specific flashcard, but I do have 2 variables that have a relationship. That's card 5. If I flip this over, this is supposed to remind me that I need to calculate conditional distributions. So that's the first thing. And then I have this card that says, well, how do I calculate a conditional distribution? Usually based off of the explanatory variable. So I needed to use 2 ideas here. On your practice test, you have the problem with the graphs. It was the longer one. And in this case, when we calculated the conditional percents, we used the explanatory variable, your age. So in this case, the explanatory variable is gender. If it's age or gender or height, anything like that, it's always the explanatory variable because those things typically don't change. So if I want to talk about association, I have to calculate conditional distributions, which means calculate a percent. What should those percents be based off of? Gender. The percents need to be based off of gender. So association means calculate percent. When you calculate the percent, it needs to be based on explanatory. What does it mean to be based on? Think of the B's. Based on means that that's what goes in the bottom. So we want gender in the bottom. So we want to know what percent of girls went on the trip and what percent of boys went on the trip. So for the boys, so we want to know, I'm going to write that down. I guess I should use signed up. So these are the two percentages that you want to compare. This said 60 of the 100 boys signed up, 60 of the 80 girls signed up. This one is 60%, this one is 75%. I better make sure. I don't trust myself doing the math in my head. Yes. So we can't tell because the class doesn't have the same number of boys and girls. No. Yes, because the same number of boys and girls signed up. No. Yes, because a lower percentage of the boys signed up than the girls. Yes. Only 60% of the boys signed up, but 75% of the girls showed up. In order for these to have no association, the same percent of boys and girls would have signed up. It's like this problem here. If your gender doesn't matter, then 60% of the boys would have signed up and 60% of the girls would have signed up. The same percentage in the genders would have signed up. Okay, on to number 6. Oh, this problem made me so sad, you guys. This problem I thought was going to be the easiest problem on this entire exam, and most people missed number 6. So when we have talked about associations and comparing bar graphs, one thing that I would like to highlight is that we are always comparing two different bar graphs. We are always comparing two different bar graphs. So I am trying to find those graphs that I gave you after one of the quizzes that we took. This is a page of looking at association. And something that I want you to notice is we are always comparing one group with the other, always. So we're comparing one variable or one group with another group. The other thing that I want you to notice is, are any of these bars the same length? And by the same length, I mean this. When we have talked about looking at association, you have never seen bar graphs that are the exact same height. Ever, ever, ever. Never, ever. So, even on your practice test question, these are variables that have no association. None of them are the same height. Lots of you guys understand that if there is no association, then the bars look the same. But what you misunderstood was the bars between two graphs look the same. Not the bars are the same length. The bars between the two graphs are exactly the same. So if we go back to this problem, this is treatment A. So what would treatment B need to look like for these to have no association? Well, they need to look exactly the same. The two graphs have to look exactly the same. So that's what you're seeing in this practice test problem with these graphs. You could have made two side by side, but notice you're comparing two and they look the same. You could have done right next to each other. Two graphs, bars are the same height. You could have done segmented. Bars are the same size. The only time you ever get this, the only time this ever means association is if you have another graph you're comparing it to and it looks exactly the same. So almost every single person chose number or letter A. And that confuses me because you've never seen something like that in class before. And while we're on that topic, let's move on to number 7. While we're on that, let's look at 7. Because this asks you, how many stems would you need to add in order to add a battery life of 40 hours? Now, the key was kind of weird. I don't understand why they said it's 420 to 429. That's not the case. 4 bar 2 represents 420, and that's it. But I'm not sure that it was the key that messed you guys up. So you had a practice problem on this in the practice test. What a lot of you guys were doing was like adding stems to this side of the stem plot. You've never done that. When have we ever done that in class? Never. So I don't understand why so many of you guys thought that you had to go the other direction. For these tests, I'm not trying to trick you. We're not trying to trick you. We're trying to get you to apply your information in a slightly different way. So we're not asking you to do something that you've never done. We're just asking it in a different way, kind of. So let me explain that further. On your practice test, you had to add stems on the end. So you had to add 2 stems down here. But on the test, you were supposed to apply the same reasoning and understand that if this was less than 100, you needed to add to the lower end, and your only option was zeros. So same idea, we're not asking you to do anything different. If you want to add on top of the stem and leaf, it has to be a 0. It can't be 1, 2, 3, 4. So a lifetime of 40 would have been a 4 on the very first stem. This equals 0, 4, 0, which is 40. So the correct answer to this one is B. I'm highlighting these two together because I want you to be thinking about, on at least on your multiple choice, but even on your free response, maybe don't start doing things we've never done before or choosing things you've never seen before. I try to the best of my ability to really prepare you guys for these exams, so I would never put this kind of graph on your exam if you've never seen it. I would never ask you to add stems up here if you've never seen that you can do that. And you can't do that. That's why you've never seen it. Okay, next up is 8. 8 also made me sad. So you should be familiar with all of the different shapes of data. So if we go to all of our different shapes, we have them on our cheat sheet. So we probably should have made a flashcard with all of these, because I want you to notice what a uniform distribution looks like. This is a uniform distribution. A uniform distribution means that your bars are all about the same height. There are no modes. There are no modes, no peaks. These are all about the same. So if we come back here, the thing that messed you guys up the most was symmetric and unimodal. You guys got caught up on this idea of unimodal and thought because you have 2 bars here that this is not unimodal. But really it is. You have a peak from 9 to 9.2. You have a continuous peak. If these would have been separated like this and been the same height, then it would have been bimodal. But they're not separated. You have a continuous peak. But even if that was making you nervous and you were unsure, none of these are uniform. Not even close to uniform. Bimodal, right skewed, left skewed, symmetric, and unimodal. So A was your option, and that one would have been really easy if you would have been familiar with all of the shapes, not just bimodal, unimodal, and skewed. So you got to be careful on that one. Okay, now we're on to 9. Okay, so for the most part, you guys did really well on this. Reading through the answers, I can see that they want or are interested in the lower bound only. So they really are only asking us to, well, maybe not. Nope, we got to find both. So we got to find the lower bound and the upper bound, which most of you guys did fine. So the lower bound would be your quartile 1, 15, minus your IQR of 3 times 1.5. So your lower bound is 10.5. Well, your minimum value is 12, so there are no lower outliers. Your upper bound is quartile 3 plus 1.5 times IQR. I wrote it backward there, sorry about that. So that's 18 plus 1.5 times 3. That's 22.5. So now this guy is an outlier. Which of the following statements is true? The smallest observation is 12 and it's an outlier. No. The largest observation is 24 and it is an outlier, and no other observations can be outliers. Well, this tells us that there were 10, the number of hurricanes of the United States was recorded for the last 10 decades, and the summary measures are shown. These are not the only values in the data set. These are the only values that we know. There could be another number at 23. There could be another number at 23.5. So, well, no, not, there could be another number at 23 because it says the number of hurricanes. You can't have 23.5 hurricanes. So there could be 23 below that 24. We don't know. All we know are these 1, 2, 3, 4, 5. Oh, it does tell us 10. Family. Holy moly. So n is 10, which means that okay, I understand the problem now. Okay, so for each decade, they counted up the number of hurricanes. So in one of the decades, there were 24 hurricanes. So maybe in another one of the decades, there were 23 hurricanes. We don't know for sure. So that's the issue with this problem. They only give us 5 numbers from the data set. So there are another 5 that we don't know, and we can't even really say for sure that 24 is in the data set, or just kidding, not 24, your median. We can't even say for sure that 16 is in the data set. Maybe we could if we looked at these other ones. But what I'm getting at is we don't know all of the data values, so we can't say B. Both 12 and 24 are outliers. Nope. 12 is an outlier. Nope. Which would have to leave E. 24 is an outlier, and it is possible that there are other outliers at the high end, because one of the decades could have been 23, but we don't know because we only got the summary statistics. And then lastly, it says, based on the dot plots, what is the greatest percentage of moisture in the corn? So you could go through and calculate all of these, the first quartile, the median, the third quartile, the range, the interquartile range. But if you look at the min and the max, notice that for the corn, the min and the max are, well, the minimum is lower and the maximum is higher. So it is D. The range for corn is bigger because its min and max, the min is lower and the max is higher, its range is bigger. I did go through and calculate all of the things. If it doesn't take me 10 years, I'll show you on my exam. I gotta pause and I'll go find it. So here are the stats that I pulled for this. I found the max, the min, the range, and then after that I was gonna find the median and the quartiles. But I realized just doing the max and the min that the range was bigger. Okay, so that is your multiple choice. I probably should have said this at the beginning of the video, but you should just change your answer on your exam. You should just erase the wrong answer or mark the right answer with a highlighter so you can keep track of what you thought it was. And it probably would be a really good idea if you wrote down why you got it wrong. If you can write down why you got it wrong, then that will enhance your understanding for the next time. So on number 9, instead of just saying, instead of just circling E instead of B, you should write down, we only know the summary statistics. There are 10 observations and we only know 5 of them. So that's why I got it wrong. I thought that 24 was the only outlier, but really I don't know what the rest of the data set is. And further, it would be really helpful if you understood that without really going through and looking at the lower quartile, the median, and the upper quartile, the only numbers that we know for sure are in this data set are the min and the max. Because the lower quartile, it's a location. It is the point at which 25% of your data is below quartile 1, and 25% of your data is from Q1 to the median. Just like the median is a position where half the data is above and half the data is below. So the median has a value, but it's not necessarily guaranteed to be an observation in the data set, because your values could be 24 and 26. The median then would be 25, but 25 isn't in the data set. You still use 25 as the value for your median though. So if that is not making sense to you, you're probably not ready to do the retake. So you have to keep in mind, min and max are definitely in the data set, but the quartiles and the median, without really going through and analyzing those values, we can't say for sure whether or not they're truly in the data set. And on a multiple choice problem, you don't want to spend the time to try to figure out if they are. You just want to take the values and recognize, okay, 24 is an outlier. I don't know what's below it, so there could be one at 23, and then move on with your life. Hopefully that helps. If you need more guidance with that, come in and let me know and we can talk about it. Otherwise, hopefully this helped. Hopefully this gives you some idea of where things went wrong and gives you an idea of what we could talk about if you need me to help get you ready for your retake. Otherwise, make sure you go through and you mark the right answers, and I would challenge you to write an explanation of how your thinking has changed or what the right answer was, because if you can explain it, that means you understand it. If you can write it, that's the best way, one of the absolute best ways to learn something. And if you don't want to write it, say it out loud. Pretend like I'm sitting in the room with you and explain it to me. I'm sitting in the room all by myself right now. So explain to me what you got wrong, because writing it or explaining it is going to increase your learning and enhance your memory retention exponentially. So that is that. Maybe take a break and we'll go over the free response, because that was a disaster. Okay. Love you guys. Hopefully that helped.